Okay, so this is the key to quadratic equations number 2, and in this case we're starting to solve quadratic equations. Now make sure you read the directions. The direction says you must use the square root property. So do not FOIL this out, put it in standard form and use factoring. That's not what it's asking you to do. You must follow directions, okay? So it says you must use the square root property. So let's talk about that. All right, so here's number 1. So number 1, we have 2x minus 1 squared equals 16. So that's the original problem. Let me go ahead and rewrite this over. 2x minus 1 squared equals 16. All right, so if I'm going to use the square root property, I first of all have to get that binomial squared by itself, okay? And then the opposite of squaring, just like when you solved a square root equation, you squared both sides. Here I'm squaring this binomial. I got to get this binomial by itself. So the opposite of squaring is to take the square root of both sides. But here's the issue. So remember, whenever you take the square root of both sides, just like you remember when you had the square x squared equal, let's say 9, when you took the square root of both sides, there are two solutions, plus or minus. So your solutions are x equal plus or minus 3, a positive 3 and a negative 3. So don't forget that plus or minus symbol. That's important. Don't forget that. And so now the square root and the square undo each other. So you get 2x minus 1 equal plus or minus, and then the square root of 16 is 4. Okay, now listen carefully about what I'm about to say. If this right here is a perfect square, 16, and you see that, and it was, so you no longer have a square root, right? If you no longer have a square root, here's the way it needs to be solve further. You have to split this up like this. So you have to say 2x minus 1 equals 4, 2x minus 1 equals a negative 4. So you're going to write two linear equations. So again, I'm going to say it again. If this is a perfect square, you're no longer going to have a square root symbol in this part. So split it apart like this. Because what's going to happen is you're going to end up with two rational solutions. That's what you're going to end up with. Okay? And you must show the two rational solutions. Okay, so I add 1 to both sides. I get 2x equal 5. Divide both sides by 2, and there's one of my rational solutions, 5 halves. Over here, add 1 to both sides. I get 2x equal negative 4, and a positive 1 is a negative 3. Divide both sides by 2, and here's the other rational solution. So there are the two rational solutions. Okay, so again, if this is a perfect square, you're no longer going to have any square roots. You go further, you write it like this. All right, so that was the answer number 1. So here are your two rational solutions. So your solutions are x equal 5 halves, and then the other one is x equal negative 3 halves. Okay, number 2. Number 2, we have this. We have 6x plus 5 squared equal negative 25. All right, so notice, I want you to first of all notice that this is a quadratic equation. And it's a quadratic equation because if you did FOIL this, which you're not, but if you did FOIL it, you get 6x times 6x is 36x squared. So it is a quadratic equation. But I want you to notice, though, that this left side is in factored form. So you have this factor that's being squared. So leave it like this. Use the square root property like they ask you to. So leave it in factored form. Okay, now what you want to do next, though, since this binomial squared is by itself, you want to get this binomial by itself. So you want to get rid of this square. So if I rewrite this over, and be careful, this is negative 25 on this side, I'm going to take the square root of both sides, just like this. And don't forget the plus or minus. You must write plus or minus right here. So the square and the square root undo each other. So you get 6x plus 5 equal plus or minus. Now remember the square root of a negative 25, what that is. So the square root of a negative 25 is just 5i. And so this is 5i. Okay, now, how do I write this? Okay, that's a good question. All right, so notice in number one, I had this real number, right? Square root of 16 is a real number. No square root. So you wrote it as two rational solutions. Here, though, that's the square root of negative 25 is not a real number. So you get this imaginary unit here, imaginary number. So since I'm going to have the imaginary number here, and this is going to be a complex number, so we're going to now deal with a complex number. What you're going to do is you're going to just subtract 5 from both sides, just like this. Now be careful. Be careful. Those are not like terms. Those are not like terms because that doesn't have an I with it. So when you combine like terms, you're going to say 6x equal negative 5 plus or minus 5i. See that plus or minus 5i? That goes together. Put it together. This goes in front. And then you can divide both sides by 6, just like this. And so you get x equal negative 5 plus or minus 5i divided by 6. And that's your solution. You have two solutions. If you want to, now in my math lab, they're going to ask you to separate this. So you're going to say negative 5 plus 5i divided by 6, comma, negative 5 minus 5i divided by 6. Okay? Now, if you wanted to write this as two separate fractions, you can. So there are multiple ways of writing this. You could have also said in my math lab, you could have also said negative 5, 6 plus 5, 6i. 5i divided by 6. The other one, negative 5, 6 minus 5i divided by 6. So all those are correct. Okay, all these are correct. Correct ways of writing the answer, the solution. But notice how I wrote this. So here, the 16 was a perfect square. So you told me what the two rational solutions were. So that's how you worked it out. It's got to look like this. Here, though, since the square of negative 25, I end up using the imaginary number. So I'm going to end up with two complex solutions. So these are complex imaginary solutions. All right. So therefore, you're going to write it like either like this, or you can separate it. Okay. All right. So that was number 2. So number 2, I'm going to go ahead and write it like the first one. So it was number 2. We're going to say x equal negative 5 plus or minus 5i divided by 6. Okay, number 3. So let's number 3. So number 3, I have this. I have 2x plus 3 squared equal 3. Okay? Now, so again, notice that I'm solving this quadratic equation. This is quadratic because if I FOIL this out, I would get 2x times 2x is 4x squared. So it would end up being quadratic. But I don't want to FOIL this out. I want to use the square root property. So whenever you have a binomial squared or something squared equal a number, then use the square root property. It makes things a lot easier for you. And in fact, the directions just say use the square root property. So let me go ahead and rewrite this over. Okay, now to get rid of that square, so you're trying to get 2x plus 3 by itself. So right now you're squaring it. The opposite of squaring is to take the square root of both sides. But remember, don't forget that plus or minus over here. So the square and the square root undo each other. So you're left with this radicand, or this binomial, 2x plus 3 equal plus or minus. Now remember, compare that with number 1. You see, number 1, 16 was a perfect square. And so you saw how to rewrite your answers. Number 2, 3 is not a perfect square. And it's not an imaginary number either. So you're going to leave it at square root of 3. You cannot simplify this, right? There's the only perfect square that goes into 3 is 1. And then you're going to the rest of this will look just like you did this, except you won't have the imaginary unit. So in other words, you're going to say, all right, I'm going to subtract 3 from both sides. See how you did this right here? How I subtracted 5 from both sides, and then you said negative 5 plus or minus 5i. Same thing here. So this will be 2x equal, this is 0. So you say negative 3 plus or minus square root of 3. Now notice those are not like terms. We talked about that. This has a square root. This does not. And then the next thing you do is just get x by itself, divide by 2, and you're done. So if I divide by 2, I get x equal negative 3 plus or minus square root of 3 divided by 2. There's your answer. Now in my math lab, they're going to ask you to separate this. So if I separate those solutions, I'm going to get negative 3 plus the square root of 3 divided by 2, comma, negative 3 minus the square root of 3 divided by 2. And again, if you want to rewrite as two separate fractions, you can. So you'd say negative 3 halves plus the square root of 3 divided by 2, comma, and then negative 3 halves minus the square root of 3 divided by 2. Okay? Many students, though, will leave it like this. That's the one they'll leave it as on a test. In my math lab, though, you're forced to write it like this. You cannot write, in my math lab, if you write it like this, it's going to be marked as wrong. So you got to write it as two separate solutions. Okay, so that was number 3. So number 3, the way you solved it was the same way you did number 2, that process right here. Okay, so number 3, we have negative 3 plus or minus the square root of 3 divided by 2. Okay, now number 4. Number 4, we have this. Number 4, we have 5x minus 2 squared equal 12. So again, I'm solving this quadratic equation. I want to use the square root property. If I'm going to use the square root property, I have to have the part is being squared by itself, and it is. So let me go ahead and rewrite this over. So once you get that part that's being squared, the next step is to get rid of that squaring. So the opposite of squaring is to take the square root of both sides, just like that. Don't forget plus or minus. So the square and the square root undo each other, so you're left with this binomial, 5x minus 2 equal. Okay, now let's go back and talk about number 1 again. So number 1, this 16 was a perfect square. You did not have a square root in this part. So you wrote it as two rational solutions, just like this. You broke it apart. Over here, when we talked about number 3 was not a perfect square, all right, but I ended up with this irrational number. So all I did was I just rewrote it. I left it as plus or minus, and then divide by get x by itself. And then on my math lab, you separate it like this or like this. Notice though in number 4, 12 is not a perfect square, but I can simplify the square root of 12, and you have to. You can't leave the square root of 12. You're not going to get full credit. You'll get most of your points, but because you did a lot of the processes correct, you just didn't simplify the square root of 12. So the square root of 12, remember, is the square root of 4 times the square root of 3. So that's 2 square root of 3. So that's what you need to put here. So this is plus or minus 2 square root of 3. And now you're going to get x by itself. So one way is just to add 2 to both sides like this. Now be careful. Don't say 2 plus 2. These are not like terms because this does not have a square root 3 here. So what you have to do is you're going to have to rewrite this as 2 plus or minus 2 square root of 3. Those are not like terms. And then finally, all you do is now divide by 5, and you found your answer. X equal 2 plus or minus 2 square root of 3 divided by 5. So you have, in this case, you have, now I forgot to mention it here as well. So you remember when we described this as two rational solutions and this as two complex imaginary solutions? So here, remember square root of 3 is irrational, so you get two irrational solutions. So two irrational solutions. And then over here, it's the same thing. Square root of 12 is irrational, so you get two irrational solutions. All right. And so there's your answer. So those are your two irrational solutions. Now, in my math lab, you're going to rewrite those two irrational solutions as 2 plus 2 square root of 3 divided by 5, comma, 2 minus 2 square root of 3 divided by 5. Or if you want to rewrite them as separate fractions, you can, to be 2/5 plus 2/5 square root of 3, comma, 2/5 minus 2/5 square root of 3. Okay? All right, so that is the key to worksheet on quadratic equations number 2. Let me go ahead and just put the answer right here. So that answer is 2 plus or minus 2 square root of 3 divided by 5. Okay, so that's the key to, and remember the work is on other sheet. All right, so that's the key to quadratic equations number 2.